I want to welcome Olga Maciaszek-Sharma. Hello, Olga.
Hello.
It's great to have you here on our virtual stage. Olga is a software engineer in a Spring Cloud team at VMware and also a contributor to various open source projects. Before switching to development, she worked for more than 3 years as a quality assurance engineer specialized in test automation, which is a very unique combination of skills. And tonight, she will tell us how to build better APIs, faster tests, and more resilient systems with Spring Cloud Contract. The floor is yours, Olga.
Thank you, Ola. So let's go to the presentation. I will not talk a lot about myself because Ola has already introduced me. Just something to know is that I now mostly work on Spring Cloud Load Balancer, Spring Cloud Contract, and Spring Cloud OpenFeign. And you can see my GitHub and my Twitter linked here. So what will we be trying to improve during this presentation and with the tools that we can use that we will talk about during this presentation? So I'm not going to pretend that I have a silver bullet, or as we say in Poland, a golden hammer that will solve all your problems. However, we will try to solve some of them. The first thing is we will try to make tests faster. So back a few years ago, back then everybody had monolithic applications, or at least most of us. And the monolith, what it has, and a characteristic that it has is that it can be tested at the highest level of abstraction. So we did that. We wrote end-to-end tests extensively. We created automated end-to-end tests, manual end-to-end tests, and they were extremely popular up until a few years ago. And we've got sort of used to the things that also came with end-to-end tests. So many of us got used to end-to-end tests repeatedly failing on environmental changes. And we have, like, I guess, quite a lot of us have probably seen deployment pipelines that will take 2 hours to execute all end-to-end tests and then fail at the last stage because there has been an environmental change that didn't have anything to do with the code. And I have seen it at least in 3 companies, I would say, really pipelines that took hours on end. And it was so prevalent an issue that the community has seen a need of adding a we need the beer plugin to the Jenkins pipeline. And even though, of course, what I'm saying is reflects the bad practices, and it does not have to be this way. And there are ways to avoid a lot of these issues if we follow certain good practices while creating end-to-end tests. The point is that the end-to-end tests and things that are tested at this last level will always be most time-taking. And very often what happened in projects is we reached a pathway, we were on a pathway to the automation, as Venkat Subramanian calls the too much prevalent UI level verification. So why did we use them? As we've seen, the end-to-end tests can be very slow and unstable. They rely on collaborators. If we have any external database or a different app, there are a lot of things that we have to set up, but they are reliable. So we mostly trusted these tests as the tests simulated directly the actual user trigger processes, and we could feel that they were reliable, they simulated user behavior, they were comprehensive, and they verified borders. So even though they were slow, we felt very safe with them, or at least safer than just with having unit tests or stub tests. However, what happened then? A lot of us have moved to microservice architectures. And this is not to say that this is the optimal and the best architecture. However, in today's world, there are many use cases where this ends up being the most convenient architecture to solve a given problem. And as we moved to the distributed architectures, we also had to learn not only how to develop the code differently and deploy it differently, but also how to test it differently. So we divided our code bases, and now we had the small teams working on small code bases to introduce features faster and do fix any bugs faster. And then, of course, we also want our tests to be fast. Also, we have managed to decouple the way that we develop our applications. So uh, that is sometimes overlooked, but actually it's equally important, if not more. What we should have in order to have a reasonably working microservice environment is also decoupled deployment. So we need to be able to deploy our applications separately. And that also means that we cannot have a huge environment where we'll be deploying all the applications and managing versions of these applications and only testing with the end-to-end test and then deploying the versions of our applications that have to go together. So that would be deployment coupling. We don't want that. We want to be able to test and deploy any given service in our microservice ecosystem individually. And as we had now agile teams, we also wanted to have agile releases. We wanted to report the benefits of continuous deployments or even continuous delivery. So again, we needed faster tests. Another thing that happened is that our industry has realized that things will always fail. So there was this time where we thought that if we write very extensive documentation of any new feature, and we have a team of 5 analysts that discuss it, and they take half a year to write it, then we develop it for another half a year. And then we have 3 independent teams of testers that will run automated and manual end-to-end, all sorts of tests, and will take another 3 months. And then we will do a code freeze that will last 1 month. Then if we push it now to production, everything will work. So at some point, we have realized as an industry that that has never happened, that this approach and this principle that we believed in has been failing us altogether. And we realized, even with the monolith, that things will always fail, there will always be errors. And what we need to do instead is find a way to make it safe to fail. So we know that things will fail. We just want to be able to revert the changes and, first of all, find the changes that cause the issues as fast as possible. So we need to have small deployments because only then we have a very small piece of like set of commits, let's say, that we need to go through to verify which one of them has caused the issue. Then we need to be able to create a fix very quickly, test it very quickly. And this is important to actually test it, not to just push some patches to production in some different way. No, because we can be introducing regression issues. So we want to test it fast, and then we want to be able to deploy it fast. And this becomes even more important as we move to microservices, because as Susan Fowler says in Production Ready Microservices, in the microservice environment, if there is something that can potentially fail, it definitely will. So this is very important. We need to make it safe to fail. So as we had to adjust to all these changes and make our testing process much faster and much more stable to make our deployments faster and stable, what happened in the industry in general was a shift to the left. So we started moving our tests this way. So more unit tests, more integration tests, much less end-to-end tests than what we were used to before. So much less of this reliability at the same time. And for the integration testing, again, we wanted to avoid the lengthy network communication. So we started using stubs. And stubs are very popular. There are several frameworks that can, for example, allow you to imitate an HTTP movement. There is Hoverfly, and there is WireMock that I'm going to show you here. So with WireMock, it's sort of an in-memory HTTP server that will behave as you tell it to. So if you describe an interaction like the one I have in the slide, you're telling WireMock in this JSON that if I send you a request with a GET method and with a URL endpoint X, let's say, then I want to get from you a response with status 200. And that works extremely well. So WireMock is a great tool, and it will feed us all these stubbed responses when we do the right request during our integration tests. So we write our stubs as the consumers, so the apps that consume somebody else's HTTP API. And then we test against these stubs. So what can go wrong? Everything works. We've written the stubs, we've written the test. It's awesome. What happens, however, a lot, and I've seen it a lot in production, it happens all the time, is when we only test it with stubs, when we ship it to production, things fail. And there is a very simple reason for that. So, for example, in our scenario, the same team usually, or even the same person, creates this stubbed interaction, and from the consumer team, so the team that is running the integration test, pretending there is a different app that has an API, but instead having this WireMock server. So they sort of write this stub, which is the description of what they think the production server on the other side will return, and it does not have anything to do with what it actually returns. Because as in this example, for example, just the URL could be endpoint Y, and it will already fail in production. Because unfortunately, this is just wishful thinking. So this is how we want the production server to behave. This does not have anything to do or does not give us any guarantee that the production server actually behaves this way. And the same thing happens with messaging. So we can have sort of stub routes. Many frameworks provide tools to stub messaging routes for integration tests on the consumer side. But again, since we just describe how this stubbing should look like, and then we test against it, we are not aware many times that our production and the other side looks slightly different. For example, the topic is different. Or this is even more prevalent, the framework that we use, so the stubbing framework that we use and the testing framework that we use to verify our messaging interaction does not verify this realization and just uses the same POJO that we used for stubbing. And then what can happen is that actually in the server, they're expecting a product ID field, but we have an ID field. And then if we have only tested against stubs in our integration tests, and we didn't test it with end-to-end, when we go to production, things will fail. So to summarize, stubs are great for prototyping, but if we have stubs alone without contracts and we test against them, these tests and these stubs do not guarantee absolutely anything. So going back to this, contrary to end-to-end tests, stub tests are very fast, very stable, and independent. We do not need to set up anything in our environment. However, they're extremely unreliable. So that was a short description of the first problem that we want to try to solve. And when it comes to the second problem, better APIs, starting again with the monolith, before we didn't really have a lot of APIs. So we had a server with some limited clients. We had very limited APIs. And very often these APIs were public or external. So first of all, they would not really change, or they will only have a new version possibly. And then we didn't care that much about them. So yeah, of course, we sort of cared, and we also gave our users documentation. But if some of you integrated with external APIs of some systems based on documentation, you will know that more often than not, the documentation no longer reflects the API. But people lived with that because there was no other way of doing that. This was a public API and it was difficult to collaborate. And we also had limited network communication for our internal apps, so there was much less of it. But then, in a microservice scenario, network communication has become a first-class citizen. And now we have multiple instances of many services communicating with each other over the network. And we have a lot of APIs which are fast growing and even changing. So we wouldn't usually change a public API in the same version, but it does happen with internal APIs in companies. And then what we have is a possibility to collaborate between API producers and consumers. And that's a really good news. Before we go deeper into that, let's say what a producer is and what a consumer is. So for the purposes of this presentation, a producer is any app that either exposes a REST API or sends messages. And then consumer is an application that will send requests to that API or consume the messages. So going back to the collaboration between the producers and the consumers, I am guessing that at this point, probably many of us are asking yourself the question, why would we want to do that exactly? So if we are the producer team, then we own this app, we have built this API, we know this app best, and we also know how to build this API. But then, do we? So even though I guess that many of you that work with code have seen a lot of times code that seems to have been written with the idea in mind of this code was hard to write and it should be hard to read. And then at some points we turn on the blame feature and we see our own name, but that's a different story. So even though that does happen in practice, we still know that we actually should make our code in a way that is easy to read and not easy to write. Why? Because the code is usually written once, sometimes modified, but is read a lot of times. So actually, readability is super important. And it is very similar with the API. So although the producer team usually has to create it, it is the consumer team that has to live with it later and use it all the time. So they really often know better what this API should look like to be practical and usable. And that's why it makes sense for the consumer to actually drive the creation of the API. And this is something that many of you might have seen in practice if you happen to create an app where you had to create some kind of a front end and a back end. And if you did it right, then you probably started with the front end and what requests it will be sending to the backend. But if you are mostly a backend engineer like me and you started with the backend and first created the API and then decided to add a front end layer, you usually would soon realize that if you started working from the other way around and thinking what request I want to make and what information I actually want to display, that would have been much easier. So that's why it's important to involve our consumers in the creation of our APIs if we have this possibility, if we work in the same company. However, the problem with human collaboration is that if there are no appropriate processes and safeguards in place, things tend to go wrong very easily. So now I would like to show you a potential answer to both of these problems, which is the consumer-driven contracts approach. So what is a contract? A contract is a set of codified rules that defines that if the consumer sends an input A, the producer should respond with an output B. And this can actually, the definitions of these inputs and outputs and of this interaction can look very similar to what we have seen before while looking at the WireMock stubs. However, there is a very important difference. So the big difference is that the contract has to actually be enforced or guaranteed for it to be a contract. And any contract testing frameworks will provide this capacity. So we will show this with the example of Spring Cloud contract shortly. But if you are using any other contract testing framework, this is also the main rule. So you need to guarantee that this is not wishful thinking anymore, that your producer app actually behaves the way that the contract describes its behavior. So that was a contract. And going back to consumer-driven contract, as we've said, it is an approach where it is the consumer that drives the creation of the contracts and the subsequent API changes. And of course, if you think you have some novel and great and new idea in the IT industry, when you deep digger, it appears that Martin Fowler has had that idea 20 years ago. So consumer-driven contracts is not a very new idea. However, it is still new in the industry because the implementations that allow you to do contract testing, so the contract testing tools are quite new. One of the possible implementations or tools that we can use to do contract testing is Spring Cloud Contract. And let's have a look at this sample producer consumer flow with Spring Cloud Contract, and we will also look at code examples. So first, the consumer will check out the producer code repo and work locally on a contract. Why the producer code repo? Because this is not obligatory, and we will see later on that this can be modified. However, in the most popular and base scenario, in Spring Cloud Contract, we suggest the contracts to be kept on the producer side, so with the producer code. So the consumer will work on them and will drive the creation of the contracts and the API, but we expect it to be done via pull request in a Git repository. So the consumer will check out the producer code repo and work locally on a contract. And we assume one thing. So we assume the producer repo has already the Spring Cloud Contract Verifier plugin set up. So if it doesn't have it, you will need to add it. And yes, it also has to be configured. So here we are using the test framework JUnit 5, but you could also use the older JUnit version. You could use Spock. We are also setting up test mode. So since this app is a Spring app that uses Webflux, we are setting web test client. We could also use mock MVC, or we could also use JAX-RS, and we could possibly also just run an explicit app and test against that. So, I mean, we have explicit mode, which will run the entire app, and you can test against that. And then we have specified base class for test, which is something that we will see later on. And now we create our contract. So in Spring Cloud Contract, you can create contracts in various ways. We provide a Groovy DSL, a Kotlin DSL, and also YAML. So this is the one written in Groovy. And similarly to the stubs that we've seen before, we want to send a request. So in this case, we will be sending a post at the URL fraud check. So we have an application that verifies if somebody that is applying for a loan or a credit card is a fraud or not. And then in the body, we will send a client ID. And here we don't want to pass the actual ID because this can change, obviously. So we only want to set any UID will be a correct amount, will be a correct field for us. And then we put the loan amount, in this case, the amount that we have provided here. And we can also put a bigger amount, and we will expect different results. So for example, here the amount is too high. If we put a smaller amount, we will expect to get an okay answer. That's just an example. And also we provide you a lot of these ways of working with regexes, with matchers, with values of some kind and not specific values. And then we're going to set headers. And in this case, just content type, but obviously we could put more of them. And then in the response, if we get this kind of data, we are expecting to receive a status 200 and a body that says the person is a fraud and amount is too high. And then again, some headers. And here we have exactly the same contract as a YAML. If you prefer YAML, that's completely fine. Only you need to see that we do have this regex matching by UID, but it's in the matchers section. So we just put a sample UID and client ID, and then in the matchers we write that actually we are going to accept any UID based on regex, and the rest goes same. So our consumer has created this new contract. So what we are going to do is to create a pull request, and producer will review the contract PR. And now this is actually very important because sometimes people ask us, okay, so our consumers will just impose us what the API should look like. That's just not fine. And then we tell them, well, if you work with peers, you're not expected to just accept all the peers. What usually happens is in a pull request, there will be a discussion and things will be adjusted and changed, and there will be a place to discuss things and decide what the actual API should look at the end, how it should look at the end. So let's say we have already collaborated and both sides are fine with this contract and the producer wants to implement the API in this way. So what the producer will do will run the build on the PR branch. And what should happen, what the Spring Cloud contract plugin will actually ensure that happens, is that this build will fail. Why? Because the producer does not yet have the implementation of that. So does not yet have an endpoint or any logic behind that endpoint that will provide a response to the request that the consumer sends. So what we can see here is a test that was automatically generated by the Spring Cloud Contracts Verifier plugin. So this, you don't need to write these tests. They are generated automatically for you. And they verify exactly that, whether the contract is matched. So whether if we send a request that matches the contract, we will get a response from our app that also matches the contract. So that's something we can ensure, and that's how using contract is going to be different from just using stubs. We are getting the certainty that things actually work this way in the producer app. So then the producer has to actually add the required endpoint and is going to run the build on the PR branch and can then also merge the code and deploy. And as the producer runs the build, what will happen is that also a wiremux be generated. So we have already verified that our producer app behaves a certain way. So now we feel safe to actually provide a stub. It is a wiremux JSON stub as the one we've seen before, but just more complicated due to the regexes. Uh, so now, as we are sure that the producer behaves this way, we are going to create a stub, and then our consumers can use the stubs to run tests without our app running anywhere. Because now we are sure that actually this stub is not just a wishful thinking thing, it is the reflection of how our app works. So yeah, the code is deployed along with the generated stubs jar. So wherever you are deploying the application jar, say to an artifact repository, you would also deploy another jar just with stubs. And then stubs are used, stubs published by the producer are used by the consumer for integration tests. And let's see consumer build setup. So this is actually very easy to use. If you have a Spring Boot app, you just use a starter, in this case, Spring Cloud Starter Contract Stub Runner. And this allows you to easily set up the stubs for your test just using an annotation. So what we see here is the auto-configure stub runner annotation, and then you can provide the IDs of your stubs with the IV notation. So by default, they will match the group and artifact ID of your application jar with the stubs postfix, and you can also specify the port on which the stubs should be running. So uh, if you create a request at that port and the request matches the contract request part, you will get the response from the stub. So now you can have fully separated integration tests with stubs that are not just some kind of prototyping thing, but really verify your consumer against a stub that actually reflects the producer's API. And of course, it's not a very good idea to have the port number just hard coded in your test. So instead, you don't need to pass it, and you can use this stub runner port annotation to get the port. Also, if you don't like passing the IDs in an annotation, you can just use a properties file to set it. And if you are using, for example, JUnit, you can also use a rule. Also, you can use for JUnit 5, you can use an extension to get the URL at which the stubs are going and the port at which the stubs are going to be exposed. So let's have a look at the demo. What I'm going to do is I'm going to switch to the producer app first and share a different window. Okay, so this is an app that actually has this setup that we've discussed. Is very similar to what we have seen in the slides. So we have our plugin. Also, we have the dependency here. And then we have our router config. So here you could as well just have the mapping annotations and the get mapping and so on. However, since there are already many examples that we have published in the web with this approach and with the standard traditional REST API annotations in Spring, I'm adding this one, which has a router function, which is a newer functional approach that you can also use in Spring to sort of create your endpoints. So it will route any requests that come with a post at this URL and process them with the specified processor. So in the case of this processor, we are going to use the fraud detection service to verify our request. And when we have a look at the fraud detection service, I have commented out some of the code. So it should actually return values saying that our consumer is a fraud in some cases, but we are only now ever returning the response that the consumer is okay and is not a fraud. And as we see our contracts, we have two of them. So we have the one where we expect the client not to be a fraud, which should pass, but we also have a one that expects there to be a response of the endpoint given a certain data saying that it is a fraud, and we do not have this implemented. So what we are going to do is we are just going to quickly run it and check what happens. So as you see, the tests fail. Also, you see that two tests were run, even though if you look at the test directory, we have not really added any tests. So let's see the test that failed. This is the test that, and these are the tests that have failed. And these are the tests that, as you can see, they're in the target directory. So they have been actually generated for us. We have not written them. And one more thing that I wanted to show here is the test base class. So that's something we have specified in the POM in the plugin setup. And yeah, it's here, as you can see. So if we go to this class allows us to do any setup necessary for our test. So for example, here we are using the REST assured web test client, and we are just running the controller or a router in this case in a standalone mode. However, we could be just running an entire application with certain profiles. We could be, if we're using Spring on a similar framework, we could be loading some certain configurations. Generally, it's good to load as little as we possibly need to run these tests and just mock or stub the underlying business logic, because what we want to verify in contract tests is going to be the functionality of the API. So actually the API syntax and not the underlying business logic that we will verify in tests on different levels. So let's just quickly fix it. And let's run it again. Okay, it has now passed and the tests were run and they passed. And what also happens is the stubs were actually installed. So we can see that a stubs jar was installed along our application jar in our local Maven repository. And of course, if we were running already a deployment pipeline, that would be installed in an artifact repository or wherever our actual production jar goes. But since we have it locally, we can now use it in our local consumer app. So I'm going to close this window and switch to a new one. So this is our consumer app. And as we have seen, the other application producer app is not running at all. And we have an integration test added here. So we are actually going to use a service that is going to expect that some communication happens to that fraud check producer app. However, we are not running it. So what we are going to rely on is the stubs provided by Stub Runner. And as I'm not going to use a remote artifact repository, I have installed it locally. I have set the stubs mode to local. I have set this port. But as we said, we can also do it differently without setting the port. And now we can run this test. And it should pass even though the other app is not running. Okay, let me go back to the main presentation now. So similarly, we can also create a messaging contract. And here we are putting a label that describes our contract, but this will also be used in the integration test to pick the right route stubbing. And then with messaging, we can have various scenarios. So for example, we can get a message and then respond with a different message, or just a message can be triggered by a method called, like in this case, or a message can trigger some kind of behavior in the system. So in this case, we are triggering with make successful payment. So this is the method that we'll call, and that we are expecting to trigger a message. We are setting where this message should be sent to. So in this case, payments, and we are also specifying the body and the headers that we want there to be in that message. And again, without our participation, a test is generated for us to verify that this really happens in our application. And when we do implement this and the test passes, then our stub routings can be used by the consumer apps. So the stub runner will provide a stub trigger interface that can be used to sort of trigger that message. So to simulate a scenario where we are getting that message to our underlying messaging test framework. And with messaging, we currently supports Spring Integration, Spring Cloud Stream, Apache Camel, Spring Cloud AMQP, Spring JMS, and Spring Kafka. So let's see a short demo of this. Let me switch the window. So here we have a payment app that is supposed to send messages, as you can see, to a different app, which is a shop app and which will use these messages to process the purchases. So you can see the sending here, but as previously, we want to have contracts and we want to generate stubbed behaviors so that we don't need to be running this app during the integration tests of the other apps. So here are our contracts. And if we run it, we are expecting to get stubs. And now let me change the window again. We will see our consumer app. So as you can see, this app is actually going to use this stub trigger to simulate that it is getting a message. And then we verify that a method that reacts to this message has processed the data in the right way. And I know this is going quite fast, so I'm going to also link the code of all these demos, and you can go through them slowly. And also, if you have any questions, then you can ask me, for example, in Gitter, and I will try to reply. Now let's go back to the main presentation. I'm going to switch to that window again. So there are some other features that we offer with Spring Cloud Contracts. So we can, for example, instead of keeping contracts with the producer, also keep them in a separate repository. And that is sometimes important, for example, for security reason when one team cannot possibly check out the code of another team. And then we also provide out-of-the-box Spring Cloud Netflix and Spring Cloud Load Balancer integration for the consumer tests. So if we have a load balance scenario, we will pretend that the stubs are just another app that is being found, and the calls are being directed to it through load balancing. And then also, if any one of you uses Spring REST docs, we enable creating REST docs from contracts and contracts from Spring REST docs. And then something that also many people ask about is the polyglot support. So this entire tool and framework is written in Java, and in Java applications, it just works. You can embed it into your code. But we also provide Docker images to contract test and then also to run stubs on the other side if you have apps written in virtually any other technology. So you can use our Docker images and still use the tools even though you don't use Java and you don't even have Java on your machine. It will work. And then something that also people ask about a lot, do we have support for Swagger? There is a community support for Swagger files where you can write the contract in a Swagger file that we do recommend you to use if you're interested in that. What implications do contracts have in our architectural decisions? So uh, when we see this diagram of red-green refactor, I guess many of you know it. So as we start writing, working on a functionality, we can write a test. Since the functionality is not there, it will be red, it will not pass. Then we implement it, it becomes green. And then we want to improve this functionality, refactor it, and then again, we might get a red test and so on. So with Spring Cloud Contract, we are able to move this process, this red-green refactor approach on an architecture level where the teams collaborate together and start with a failing test from a new contract. Then let's say an endpoint is added and the tests are passing. And then another team wants to modify the contract. So creates a new PR and then we go again with this cycle. Also, what we get practically for free while using contract testing is backwards compatibility checks in our deployment pipeline. So what we can do in the deployment pipeline when we have a new API version, provided that we want our API to be backwards compatible, and I guess usually we do want to have it, it's always better. I know some teams internally break APIs and just have this approach. But for me, even in an internal API, it's always good to keep it backwards compatible. So what you can do is test it with the new contracts, but then test it against the contracts that are currently your production contracts. Like this, you verify that it will still not break production apps, and then you can deploy. Does this mean that we can never do any changes? No, we can, but the approach that we would use here is similar to what we do, and we do not want to break compatibility in databases. So we would do a deferred update. So let's assume we had a field build time expressed in seconds. So our contract had a field build time and our application response had a field build time, and it was in seconds. Then we realized that that was actually a bad idea and we really wanted to have it in milliseconds. So what we would do, we would first only add the new fields to both the contract and the application. So our users will start seeing that now our producer app is also returning this field. And then they will start switching to it. And we will also enforce it because we will remove the old field, but only from the contract at first. So our consumers will see that the API is different and they have to adjust themselves. And then once everybody has had time to adjust, we can remove the old field also in production. And like this, we have transitioned from the old version to the new version without breaking the entire production. Some important things to keep in mind and lessons that I've learned along working with contracts, because before I was working on developing this tool, I've also have been just a user of it. So first of all, in order to avoid too much troubling maintenance, I suggest that you only test your API syntax and your API layer in the contract test, and not the underlying business logic. The underlying business logic can be tested in your unit test. So we don't think that you should be now if you had all the end-to-end tests that were testing both the integrations and the logic. Many teams would like to use contracts. It's a handy tool and do all this verification of the, again, integration and the logic. So many different scenarios with the contract. But we do not really recommend this since that brings a lot of maintenance. So we recommend you test your API layer with contract tests and your business logic layer with lower level tests. Then if you're going to resign from a lot of your end-to-end tests, you might want to introduce other practices to make your systems more resilient. So definitely you will need monitoring, logging, and alerting. Then again, you might want to skip contracts for non-essential functionalities. So again, here, since we are shifting to the left, we definitely want to have way more contract tests than we would have end-to-end tests in this approach. However, if you have a functionality that nobody ever uses, gives you $1 a year, and if it breaks, nobody will even notice that, you might decide not to create a contract for that. So you cannot be extremely dogmatic. You want them to be more of them than end-to-end tests, but not necessarily every single endpoint. And then again, to avoid too much maintenance issues, you might skip multiple values. For example, again, you don't want to verify the business functionality, just your API. So you don't need to test for value A, value B, value C in the same field of your response. And I think the time is up. However, I'm going to leave you with all the resources. There is a project page. There are a lot of samples. So there's a repository with a crazy amount of samples and different scenarios. The docs can be found from the project page. And also I am linking all the code of the demos that have been shown, and also a blog post with a case study of using a contract and the link to our Gitter channel. Thank you very much.
Thank you, Olga. Thank you for this great and extremely useful presentation. I think we still have time for one question, but there is a huge and hot discussion on YouTube. So if you can, after leaving us here, join us, there on YouTube. Marcin already took part in this discussion with Daniel and Jakub, but I think you can support him
I think
there.
he will.
But the question that was asked at the beginning of the presentation was just not to forget, can you shortly compare Spring Cloud contract with Pact, or at least one thing for Spring contract, please?
Okay, so I don't really know Pact all that well. However, I do have a listing of differences and something I have written in Stack Overflow. So this contains much more information. But for now, what to me was important was the ease of use. So I think the contract, well, this is very subjective. And of course, I'm a committer of this project. So for me, the way of writing contracts in this kind of Groovy DSL or Kotlin DSL was much easier to use than what you do in Pact. But I will also link the response I've added in Stack Overflow once, listing more differences. So if you can have a look at that, that would be helpful.
Mm-hmm. So I hope Daniel heard you, and he will wait for your links on YouTube. So once again, thank you very much. It was great to have you here, and
Thank you.
see you on YouTube.
It was awesome to be here. Thanks a lot, and thank you all that have participated. Thanks for watching.